Okay, this is a quick introduction to the modulus function and its graphing. I'll do a second video on the equations and inequalities because that might need to be Wednesday's lesson for us to go through. So you've actually come across modulus, although you probably didn't realise it. In GCSE, when you were doing the vectors, if I had a vector A with a point over the top, you were sometimes asked what is two lines either side, and that said the modulus of the vector A, otherwise known as the size of, the length. That's what modulus means, is what's the size of. We don't care about the sign. So the modulus of 5 is still 5, modulus of -4 is a +4. So these two lines either side form a bracket, and the result of whatever's in that bracket is turned into the positive form. Okay, so I'll give you a couple of examples of what happens. On the graph, you can actually do modulus of x, and hopefully you would all realise that modulus x, I'm not going to plot it properly, but the modulus of x will take a set of axes. I'll draw the axes in. I'll do them quite quickly but small. So the modulus of x says that any number where x is positive, we draw the line is the same. So x is 0, x is 1, output is 1, x is 2, the output's 2, and x is 0. It is not a negative number, it's neither negative or positive, so modulus has no effect upon 0. If we kept going backwards, this line y equals x would continue like that. But the modulus says when x is -1, it goes in, change the sign, and it becomes +1. Negative 2x goes in, change it, +2x comes out. So we wind up with a function that does a nice V shape in the middle. So let's go into trying to do the modulus of 2x -1. So that's my first function. Well, start off trying to sketch the graph of 2x -1 without the modulus. So I'm going to put, I know it goes through -1 there, and it has a gradient of 2 for 1, 2 for 1, 2 for 1. So my line for the 2x -1 gives me this line, and I'm going to label it down the bottom, 2x -1. Now for all points where it's negative, it goes below the line, you reflect it up. So the actual reflection of this leads us to a line doing that. So we reflect these points going up. Okay. Try another quick one. Let's go for fairly classic. Oh, sorry, auto-label it. Modulus 2x -1. I tend to show the modulus. Normally I tend to go to the right, but when I'm showing a modulus, I try and show one where the modulus has acted when I'm labelling my functions. It's just a personal style thing I'd like to do. Let's give you modulus of this function. So g is the modulus, and I'll do this one in red so it hangs out and we can use the same axes. So g equals the modulus of x squared -3x plus 2. And you need to think, what is this graph? So you start thinking, well, what do I know about the graph? And one thing we can say is, well, I know it's got two roots. We know it's the parabolic. There's only actually one parabola. The others are all stretched and moved relative to it. So this is a parabola where we have inside x -1, x -2. That means I've got two roots. One at x is minus 1. No, sorry, one at x is 1. And one at x is 2. The parabola drops down. And we know it goes through plus 2 when x is 0. This sort of logical thinking is important because that's the sort of thing you'll be asked to do. You'll be asked to sketch graphs but clearly indicate points where it crosses the axes. So in mine, I've actually got scale going up to 5, minus 5 with 0 in the middle, and 4 vertically, and minus 4 down. It's enough to show roughly how big your axes are. You can put numbers marking the point, so I could put 1 and 2 to be clear on them, and 2 over here. That's worth doing, is actually labelling that point with where it is crossing the axis. So we know the quadratic is going to come in when it's 1, minus 1, 4, 6, so it's going to come quite steep down from there. So we've got a dotted line coming through, goes through the bottom point, and then we have our line of symmetry. So that point and that point should line up, and we're going off up. What does the modulus do to it? Well, all points where it's above the line, draw in the line. All points above the line, draw it in. And anywhere where it's negative, it flips over. So that one is the modulus of x squared minus 3x plus 2. Other things they can do with these graphs is try and get you to say where certain things happen. So let's just scroll down a little bit. Sorts of things that sometimes happen is they'll ask you to graph this one. So we've got a new function where f of x is equal to modulus x squared minus 1, and then on top of that add on 2. So you need to be able to do your graph transformations. Same as what we did with the one before. First of all, we think, what are the roots of this equation? Hopefully you'll recognise dots, difference of two squares. So we've got two roots, x is minus 1, x is plus 1, and when we draw our axes, drawing axes, moving a little bit. So we've got to break this one down, and it is worth doing the sections separately, even if you do it as a separate diagram. We know the difference of two squares gives me my axis at minus 1, plus 1, and we know it's going to be quadratic, coming down, crossing at minus 1. So label, don't label that point yet. So my curve does this piece, follows that back. And like most teachers, my curve probably is closer to being a hyperbola than a parabola. A lot of teachers make that mistake because it starts looking towards the end straight. It should keep curving up. I just want to grab a razor and tidy my diagram up a little bit, please. Okay, so that's the x squared minus 1 part. To show it as x squared minus 1. We then need to do the modulus, but this isn't the final version of my equation. So we do the inversion for the modulus part, and then what does a plus 2 do to all points on the graph? it actually raises the point up. So this is, hopefully can remind you, is a translation of 0, 2. Move the graph up 2 places. Because this is saying whatever the function f is, whatever this is, but 2 places higher. We've moved it up 2. So move it up 2 means I'll move to there, to there, to there. It doesn't cross the x-axis anywhere. And if I wanted to be clear to the examiner I knew what I was doing, I would show them those 2 points where we're at the minimum. So we would have 1, 2, minus 1, 2, and it crosses at 3. Okay? So that's one sort of thing that can happen. You might get asked occasionally questions to do with it. So how many solutions are there in different ranges of values? So in y value, if we were saying how many solutions does this have for equal to 1, there are none, because there's nothing along this horizontal line. How many solutions do we have at 2? We have 2 exact solutions. How many do we have at 2.5? Well, there would be 4 solutions. 3, we get down to 3 solutions, and 2 solutions either side. It's one of those sort of things that sort of thing is the sort of thing that might come up in an Olympiad type question. Okay, so